All right, well, welcome everyone. This is Charles Ely. Um, because of the number of people on the call and so forth, we're going to have you muted for the presentation, which won't take more than about 15 or 20 minutes, and then everyone will be unmuted, and we can go back through the material and discuss it and talk about it. So I hope this is not too inconvenient. This is the second of a series of seminars on COMNET, vetting seminars. Ellen Franconi can't make it today. She's sort of the one that's hosting it, so I'll be taking her place, I guess, today. Um, if you have the COMNET manual downloaded, the part that we're going to cover today is Chapter 2. Uh, and But before I get started, though, some of you asked before to see a schedule of the seminars, and we've developed such a schedule. It's shown here on slide 2. Um, the time that we've settled on for these seminars is 9 o'clock Pacific time, noon East Coast time on Thursdays. So today we'll be covering Chapter 2. Next week, Mangesh will cover the standard 140 portion of Chapter 3. We're going to split Chapter 3 into 2 sessions, and then a week later, on August 4th, I'll be covering the general software requirements and the modeling assumptions and baseline building tests. So Chapter 2 covers several functions, and we're going to review those today. General input from users, what's required. There's a section on thermal blocks and how they're defined. We define what's meant by unmet load hours. And then there's some general sections on the calculation procedures and HVAC capacity requirements and sizing, in particular for the baseline building. Couple of things to note right at the beginning. COMNET only works for complete buildings. It's not set up so that you can model just the HVAC system of a building, or just the envelope of a building, or just the lighting system of a building. You need to have a complete building description. The second point is that there's advice to users on how to set up the models, and building envelope can be put in great detail, or it can be simplified. And there are some rules about how it can be simplified. If there's small areas that represent 1% or less, those can be just combined with other areas. Surfaces that are within 45 degrees of each other can be combined. The third point is that every space in the building must be classified, and COMNET has these building classifications, which are consistent with the lighting classifications in 90.1, but we've also mapped them to California's Title 24 and all versions of 90.1. So every space has to be classified, and users, there's some guidance on how you can approximate troubling building features, and the key point there is that when you approximate building features, you should be conservative. It should be done in a way so that the percent savings are estimated on the low side. Moving on to thermal blocks. Thermal blocks, I'm sure most of you are familiar with this concept. Thermal blocks are thermal zones, and they make up the building model. A thermal block can consist of one or more HVAC zones, and then in turn the HVAC zones can include one or more lighting space functions. So, for instance, you could have an HVAC zone that included um, some enclosed offices, say with high partitions, and some open offices. Those would be two different lighting functions, and they could be included in the same thermal zone. You could have multiple thermal zones in the same block. So COMNET has some guidance on how spaces and HVAC zones can be combined into thermal blocks. When spaces are combined, there's basically 5 rules. They need to use the same operating schedule. They need to have the same temperature schedule, and they must have similar internal load or power densities. Internal load power densities would be the sum of the equipment loads and the lighting loads. And they ought to have similar occupant densities. And there's some guidance here. Internal loads within a range of 2 watts per square foot, and occupant densities within a range of 3 to 1. And up to 10 spaces can be combined. So these are really rules to the modeler who's setting up the rated building. Some considerations for thermal blocks and envelope loads. In general, exterior spaces and interior spaces should be separated into different thermal blocks. Um, but there's an exception for cases when the exterior space does not have any fenestration or very little fenestration. Another requirement is that exterior spaces with different glazing orientation should be separate thermal blocks, but these may be combined when they're within 45 degrees of each other, or when the fenestration area is pretty small, and the criteria there is an effective aperture of less than 10%. The effective aperture is basically the product of the window wall ratio and the solar heat gain coefficient. Then the third guideline is that spaces without floors or roofs shall be separate thermal blocks. So if you've got a multi-zone building, the spaces on the top floor ought to be separated. The spaces on the bottom floor should be separated, but ones in the middle could be combined. And HVAC zones can be combined when they have similar space conditioning requirements, but they also need to have the same type of HVAC system and similar minimum airflows for outside air ventilation and possibly other requirements. The rules for multifamily are that you can basically take the entire dwelling unit and model it as a single thermal block. Plenums can be either modeled or not modeled, and however they're treated, though, they need to be treated in the same consistent way for both the rated building and the baseline building. Let's move on to unmet load hours. Unmet load hours are a concept that most of us are familiar with, and they're the criteria that's used in the 90.1 performance rating method for sizing equipment. It represents the number of hours during the year when one or more thermal blocks are not maintaining set point temperature, or one or more systems are not making capacity. And this can result when equipment is undersized: fans, coils, furnaces, air conditioners, and so forth. So to kind of illustrate how unmet load hours work, I created this little table looking at 6 hours in the simulation. Um, so the first thing is unmet unmet load hours are recorded only during periods of time when the HVAC system is operating. So in hour 4, it's too hot, but it doesn't count as an unmet load hour because the HVAC system is not scheduled to run. Hour number 2 is too hot, so and if it's too hot in just one zone, then it counts as a single unmet load hour. So, for instance, if you look at hour 6, zone 1 is too hot, and zone 2 and 3 are too cold. But those all occur at the same hour, so it only counts as one unmet load hour. One of the common reasons that unmet load hours occur is user input errors. So COMNET has some guidance on what to look for. One of the problems often encountered is that you have different schedules. You know, your HVAC system is shut off, yet you're expecting to maintain temperature. So you need to make sure that all the schedules are aligned properly. Also, sometimes you miss a decimal point on internal gains or occupants or something like that, and this can cause a big problem. And the third point is just to make sure that that equipment is actually turned on and activated for all of the hours of operation. The next section of Chapter 2 gets into the general calculation procedures. If you have COMNET manual open or PDF, you might want to go to page 2-7, figure 2 in the portfolio version, because this one may be a bit hard to read. But I'll kind of walk through this. Maybe you can see my mouse here. So the first step 1 is to create the rated building model. Step 2 is the rated building model is actually modified to include what we call the neutral, independent, or prescribed modeling assumptions. For instance, if you're doing if your purpose are federal tax credits, then you have to use the California ACM schedules of operation as opposed to the schedules that you may have entered for your model. After that, the third step is you calculate the unmet load hours for the proposed design, and then you test to make sure that these are greater. They're not greater than 300. If they are greater than 300, then you go to step 5, and you have to go back and increase the equipment sizes or make some adjustments to the HVAC system in the rated building. Now this is something that doesn't happen automatically. This is something that the design engineer or the modeler will have to correct. And then once you pass the test of unmet load hours less than 300, then in step 7, the baseline building is created following the COMNET and performance rating method rules. And the HVAC system for the baseline building is sized, and the heating system is oversized by 25%, and the cooling system is oversized by 15%. And then the next step 9, is you calculate the unmet load hours for the baseline building and check to see that it's less than 300. If it's more than 300, then then you have to make some adjustments to the equipment. I doubt that that would ever happen because it's already oversized 25% on heating and 15% for cooling. But the next step in step 12 is kind of an interesting one. And actually but what you do here is you check to make sure that the unmet load hours in the proposed design are not 50 hours or more greater than the baseline building. If they are, then you have to actually reduce the size of the equipment in the baseline building, and so that you meet the second test of delta and unmet load hours of less than 50. And then once you pass that test in box 12, then you calculate the baseline energy consumption for the baseline building. Then you rotate the building 90 degrees and go back up to step 9 and repeat the whole process 4 times. So you create, for the baseline building, 4 models. Each one is rotated 90 degrees. Then we're getting to the bottom of here. In step 16, you calculate the baseline energy consumption as the average of the 4 orientations. And then you compare that to the rated building and calculate the percent savings. The next section in Chapter 2, Section 2.5, addresses how HVAC systems are sized. Any size adjustments to the rated building or the proposed design have to be made by the engineer or by the energy modeler, and these should agree with the contract documents, so that if the size of equipment is reduced or increased in the model, the construction documents should reflect this. The sizing of equipment in the baseline building is determined by the 20-degree delta T requirement that's specified in the performance rating method, and it's also specified by the requirement to oversize heating equipment by 25% and cooling equipment by 15%. But a special situation occurs when the unmet load hours of the rated building are 50 or more greater than the baseline building. And when this event occurs, the procedure in Figure 3, and this is Figure 2.5.2-1 of the web version, this procedure is triggered. And what happens basically is that the cooling capacities or heating capacities of the baseline building are gradually reduced so that the delta of unmet load hours is no greater than 50. So the process begins by looking to find the thermal block in the model that has the most unmet load hours, because unmet load hours need to be reduced. This is step 3. After that, you then look to see which is the greater problem. Usually it'll either be heating or cooling, and usually one or the other of those will dominate. This is step 5. After that, you look at the different system type to determine if what kind of strategy you take to bring the unmet load hours higher in the case of the baseline building. And this depends on system type. So if the problem is cooling and the system type is 1 through 4, then you look and see if the supply air CFM is greater than or equal to the outside air CFM. And if the answer to that is yes, then you reduce the cooling capacity. Otherwise, you move to step 11 and you raise the supply air temperature by 1 degree. You make these adjustments and then you go back to step 19, simulate the baseline building again with the adjusted equipment sizes, and repeat the process until the unmet load hours are within 50 of the rated building or the proposed design. The types of adjustments that you make are shown in steps 10, 11, 12 through 17, and they depend on whether the problem is mostly heating or mostly cooling, and it also depends on the system type itself, one of the 1 through 8 systems. And then the final thing in chapter 2 that I wanted to talk about is ventilation requirements. Ventilation is treated as a neutral dependent variable. This means that the baseline building inherits its ventilation levels from the rated building and is the same. So there's no credit or no penalty for reducing or adding outside air ventilation to the baseline building. The ventilation requirements shall meet local codes. If local codes don't apply, then you use ASHRAE standard 62.1-2007. And also, COMNET Appendix B has default ventilation values that are consistent, and actually they're consistent with 62.1. So with that, I'm gonna wrap it up, and thank you.